So, we've already dealt with the first objective, which is being able to sketch the graph, which involves a modulus function. Right. The second thing is we must be able to use these two relationships in solving equations and inequalities. Okay? We must be able to use these two relationships in solving equations and inequalities. Right, so we'll use the first relationship. Modulus of A is equals to modulus of B. Right. Modulus of A is equals to modulus of B means that A squared is equals to B squared. Right. Modulus of A is equals to modulus of B means that A squared is equals to B squared. Now let's have a concrete example. Example 1. Solve modulus of x plus 1 is equals to modulus of 2x plus 5. Right. In this case, for the purposes of solving this equation, what we're going to do is, as shown here, modulus of A is equals to modulus of B means that we square A squared is equals to B squared. So when the modulus appears on both sides, when the modulus appears on both sides and there's an equal sign, what we do is we square both sides. So it's going to be x plus 1 squared is equals to 2x plus 5 squared. Right? We expand the brackets. X plus 1 is equals to 2x plus 5, 2x plus 5. Right? This becomes x squared plus x plus x plus 1 is equals to 4x squared plus 10x plus 10x plus 25. Right? We've expanded this side, we've expanded that side. Then we simplify, it becomes x squared plus 2x plus 1 is equals to 4x squared plus 20x plus 25. Right, so this is an equation that we're trying to solve. So what we want to do now is we want to take everything onto one side. Okay? We move everything onto one side so that we can end up with one quadratic equation. And it's going to become, when we take everything that side, it will become 0 is equals to 3x squared plus 18x plus 24. Okay? 3x squared plus 18x plus 24 is equals to 0. 3x squared plus 18x plus 24 is equals to 0. Right, and then from here, we already know what to do. From here, we just continue and we solve using the quadratic equation or the quadratic formula. To save time, I'm not going to continue from there because that's not what our lesson is about. So from there, you just continue and you work out the rest of it. Okay? Right, let's look at another example. Let us look at another example. which uses the same relationship. Right, let's say we've got magnitude of x plus 5 is equals to magnitude of 2x minus 5. Right, as I already mentioned, when we've got the modulus function on both sides, it means that we need to square both sides. When we have the modulus function on both sides, it means that we need to square both sides. So, in this case, we're going to do the same thing. X plus 5 is equals to 2x minus 5, 2x minus 5, right? And then we simplify. This becomes x squared plus 5x plus 5x plus 25 is equals to 4x squared minus 10x minus 10x plus 25, right? And we do the same thing. Okay, we simplify first. So this becomes x squared plus 10x plus 25 is equals to 4x squared minus 20x plus 25. Right. And from there, we repeat the same process. We group everything to one side. So this becomes 0 is equals to 3x squared minus 30x, 3x squared minus 30x, and 25 minus 25 is 0. Right. So then from there, we solve this equation, which is 3x squared minus 30x is equals to 0. We already know how to solve this equation based on our IGCSE knowledge and also based on our paper 1 knowledge. And we solve that equation. So, we have managed to look at this relationship, the second type of relationship, which is modulus of A is equals to modulus of B. And we have seen that when the modulus appears on both sides, and if there is an equal sign, what we do is we just square both sides and we simplify. That is how it is done. The end result will have a quadratic equation, which we already know how to do, based on our IGCSE knowledge and our paper 1 knowledge. Right. So, now what we want to do is, we want to look at the second type of relationship. The second type of relationship. Right, let's say we've got magnitude of x minus a is less than b. Right, magnitude of x minus a is less than b. Right, what this means, magnitude of a, x minus a is less than b. Remember we said magnitude means the size, right? Magnitude. What we're saying with this statement is that x minus a lies between positive b and negative b. Okay? What we're saying is that x minus a lies between positive b and negative b. This is how we simplify this relationship. So, in order to solve an inequality of this form, what we do is we split it into two equations. We look at the first half by itself, which becomes minus b is less than x minus a. Right. We take the a to the other side and it becomes a minus b is less than x. So this is the first solution. Okay? And then we look at the other side. We look at the other side. And we split it into another equation, which will solve separately. So x minus a is less than b, right? Take the a to the other side, it becomes x is less than a plus b. And these are the two solutions that we have. These are the two solutions that we have. So x is less than a plus b, x is greater than a minus b. These two are our solutions, right? These two are our solutions. So these are our two final answers. This is how we use this relationship. Right. Now, I know it looks a bit complicated, but we want to look at an actual example. We want to look at an actual example. Example 1. No, we have had, okay. For this section is example 1, but this is actually the third example. So we'll just call this example 3. Right. Let's say solve modulus of 2x plus 5 is less than 10. Right. As I said earlier on, this statement here means that 2x plus 5 lies between positive 10 and negative 10. So this is the first step where we split this modulus into two inequalities involving the positive side of 10 and the negative side of 10. Right. Once we do that, we split this into two separate equations. And this is the first inequality, rather, not an equation. So the first one is minus 10 is less than 2x plus 5, right? And then we take the 5 to the other side, it becomes minus 10 minus 5 is less than 2x, right? And this becomes minus 15 is less than 2x. We divide both sides by 2. We divide both sides by 2. And it becomes negative 7.5 is less than x. But always our answers must be expressed with x in terms of x. So it means x is greater than negative 7.5. This is the first answer. X is greater than negative 7.5. Right. And then we look at the second half. Right. We look at the second half of the inequality. Right. Which is this side. 2x plus 5 is less than 10. Right? We do the same thing. We take this to the other side. It is a positive 5. When it goes that side, it becomes a negative 5. So it becomes 2x is less than 10 minus 5. 2x is less than 5. Divide both sides by 2. We divide both sides by 2. It becomes x is less than 2.5. So these are our two final answers, which can be expressed together. X less than, greater than. X is less than 2.5, so we write 2.5 here. X is greater than negative 7.5, so we write negative 7.5 over here. And this is our final answer. Okay? Right, just to help us clear the air, we will look at another example. We will look at another example. Right, and this is example 4. Solve modulus of 3x minus 5 is less than 2x plus 2. Right, we follow the same pattern. The first thing is to split this into 2. 3x minus 5 is greater than the positive, which is 2x plus 2, or the negative, which is 2x plus 2. Right? We're just repeating the same thing that we did when we had one number here. We just repeated the same thing. It's just that this time, since there is another linear expression, we just repeat the same process with the linear expression. Right. And from there, we focus on the first aspect, which is negative 2x plus 2 is less than 3x minus 5. We expand the bracket, it becomes negative 2x minus 2 is less than 3x minus 5. We group the like terms, take the x that side, bring the 5 this side, and it becomes minus 2 plus 5 is less than 3x plus 2x. This becomes 3 is less than 5x. We divide both sides by 5 and it becomes x is greater than 3 over 5. Right? That is our first solution. X is greater than 3 over 5. And then we now focus on the second aspect of the equation. Second aspect of the equation, which is 3x minus 5 is less than 2x plus 2. We repeat the same process and group the like terms. We bring this that side, it becomes 3x minus 2 is less than 2 plus 5. Okay? So it becomes x is less than 7. Right? It's just moving the 2x to the other side, it becomes a negative 2x. Moving the negative 5 to the other side, it becomes a positive 5. So its x is less than 7. This is our second answer. We can combine this into one answer. Right, x is less than 7, so we put a 7 there. X is greater than 3 over 5. We can put the 3 over 5 there. Right, so this is how we use these two relationships in solving equations. Our lesson ends here. I hope you enjoyed yourself. Please feel free to ask me if you've got any questions.